All right, so let's go through the next part of the proof here, now that we've set the stage with what we're going to do. So we're going to consider two expressions of a vector as a linear combination of the members of the subset. Rearrange the two sums, and if necessary, add some 0 times beta sub i's so that the terms line up. And that the sums combine in the same bi's, right? So we want all the terms to line up in the same order, okay? So here's our vector v written with this linear combination of betas, right? And here's vector v with the other linear combination of betas. So they're the same, right? So now, these two are going to equal, right? So we're going to set them equal to each other, and so it's only going to hold as long as what? The coefficients. Now, so let's write this out. So if we have this, now, so we're going to say C1 beta 1 plus C2 beta 2 plus dot 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 plus C sub n, beta sub n is equal to, hold on a second. Do I want the 0? No I don't. Right. So, yeah, so this here is equal to d1 beta 1 plus d2 beta 2 plus dot 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 plus d sub n beta sub n. Okay, so now this is true if and only if what? C1 minus D1 times beta sub 1 plus C sub 2 minus D sub 2 times beta sub 2 plus dot 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 plus C sub n minus D sub n times beta sub n is equal to the 0 vector, right? But that's only going to hold if and only if what? Well, that's only going to hold, so that asserts that what? That C sub I is equal to D sub I for I equals 1 to n, right? Because that's the only way that you're going to get the 0 vector in this case. And that every vector is expressible as a linear combination of the betas in a unique way, because we just showed that if we had the vector represented by two different linear combinations, that's what we showed here, and we showed that if they're the same, then they should be equal to each other, right? And of course, this only holds true as if we could do C1 minus D1 times beta is equal to the 0 vector, but that's only going to hold if C sub I is equal to D sub I for all I from 1 to n, which means, guess what? Has to be unique. The way that you write the linear combination of vectors equal to vector v has to be unique, so that means at most can only be one way. And therefore we proved the theorem. Have a good day.